Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 46 of Physics 5054. Ladies and gentlemen, we started the concept of temperature measurement. We differentiated between the uh, heat and temperature. Then we defined the scales of temperatures inside the previous lecture. Today we are going to uh, do the topic calculating temperature on the centigrade scale. Ladies and gentlemen, in a mercury thermometer, the physical property that changes with the temperature is the volume of a fixed mass of mercury. Instead of measuring the volume of the mercury, we can use another property that is also a physical quantity, and that is length. We can measure the length of the mercury level, and as a result we will be able to measure the temperature. Ladies and gentlemen, if we give a closer look, so temperature is directly proportional to the length of the mercury. How we will measure the length of the mercury? First of all, we have to immerse the mercury in the pure melting ice water, and then we will mark that is L0, or you can say that it is L naught. Remember, L naught we will calculate when the 0 point is here and above the bulb. So this will be L naught, and then we will immerse that thermometer inside the steam of water, and then we will measure the length from above the bulb till that area where we can find the top portion of the mercury, and we will mark that as L, and we will write a subscript of 100, just like you can see it here. From the above the bulb area till when we immerse this in the steam, so the mercury length will be increases, and that length we will denote by L100. This is when the thermometer is immersed in the ice, and this is when the thermometer is immersed in steam. Here we will denote it by 0 degree centigrade, and in the steam case we will denote it by 100 degrees centigrade. Okay, these are the two lengths, but we need another length, and that length will be the length of unknown body of which we want to find the temperature, and we will call that temperature as L theta. Theta will be written as a subscript. So you can see that this is the temperature of the body, and that is the unknown body temperature, and that is theta degree centigrade. So there are three quantities. One is L0, means ice point, steam 100 degrees Celsius means steam point, L theta. These are the conventions used in finding the unknown temperature, not by the volume expansion but by the length of the mercury level. So we cannot write it from our own side. You have to follow the international conventions. Okay, if we are taking these three values, then there is a formula with us. Theta, that is the temperature of unknown body, and that will be in degrees centigrade. First we have to write L theta minus L0. You know what is L theta? L theta is the temperature of that body in which we are interested to find. And then L0 is this one. When we immerse the thermometer inside the ice, and wherever that uh, mercury is pointing to, we have to mark that point, and that is known as L0 or L naught. Whole divide by L100. This is this one, L100. When we immerse that thermometer in the steam, and we will mark the position of the mercury, and then from above the bulb till that area we have to do what? We have to measure the length, and we have to put that value here, n minus L naught again. Okay, so we can find through a graph as well the value of unknown temperature, and that is also the most effective way of finding the unknown temperature. Ladies and gentlemen, on this x-axis we are having 2 points, that is 0 and 100. Don't consider yet this theta. I will discuss it in a moment. So this is the 0 point and this is the 100. 100 different graduation marks are there. So we only denoted 0 and 100. From here it is L naught and that is L100. Length at 0, which is this one, and length at 100, which is this one, that is on y-axis, and we are labeling it L per centimeter. That will be in centimeter, not meter, not millimeter, and that will be in degree Celsius. Now you don't have to consider this line. From 0 and L1 we will mark a point, and where the 100 and 100 intersect each other, we will mark that point as well. So we have to connect these 2 points, and it will give us a straight line which is denoted by a red line. Whenever we want to find the temperature, it will be between these 2 points, which is this one and this one. It might be somewhere here, it might be somewhere here on the red line. It will not be outside for a human body. So if we want to find the temperature and we measured the length here, So from 0 we have to mark that length. For example, we mark it is 94 or 96 or 84 or whatever. So we have to connect this point and this point, and whatever value is existing here, that will be the temperature of that body through graphical method. Theoretical method, we have this formula, ladies and gentlemen, you have to memorize. And through graphical method, we have to use this technique. And in both cases, you will get the same answer. Now, to use this formula practically, there is a work example 8.1. Let us do that and we will be able to understand the working concept of this formula or of this. The work example is given on page number 118. Ladies and gentlemen, the question is saying in an unmarked, there is no marking on it, there is no graduation on it, because we are not finding the temperature through volume expansion. In case of volume expansion, we had marked the graduation scale. So in this case, there is no graduation, and they are saying like this, that uh, in an unmarked mercury thermometer, it was found experimentally that the length L naught was 5 centimeter. We experimentally found that this L naught is 5 centimeter. This is the given data. L naught is equal to 5 centimeter and the length L100 was 25 centimeter and the L100 was 25 centimeter. So what they are asking what is the temperature when L theta is 14 centimeter. Ladies and gentlemen, the first case is 14 centimeter. So when L theta, that is the unknown temperature, is 14 centimeter, we have to use the formula. We know that theta is equal to L theta minus L naught divided by L100 minus L naught multiplied by 100. That is this formula. Now everything is given, so we have to put these values. L theta is 14 minus L naught is 5, L100 is 25 and L naught is again 5, and we have to multiply it by 100. Ladies and gentlemen, this will give you 14 minus 5, 9, and that will be 20, and that will be 100. 20 ones are and 25s are. So in this case 9 fours are 45 degree Celsius will be the temperature of that unknown body. You have to measure this experimentally, and then this, and then this. So if you are having these three values, you can find it. Now, ladies and gentlemen, in the second part, they are saying when L theta is equal to 3 centimeter, When L theta is equal to 3 centimeter, we have to use that formula again, that is L theta minus L naught n L 100 minus L naught multiplied by 100. So ladies and gentlemen, putting the values, all the values will be the same, and we will write instead of 5, 3. So 14 minus 3 and 25 minus 3, all other will exactly occurs as it is, as it was in the first case. So here when we subtract this, so you will get 3L theta is 3 and minus 5. L theta is 3 and that is minus 5. Again we have to write 25 minus 5. 25 minus 5. So only there will be one value which is changing. So this will give you minus 2 divided by 20 multiplied by 100. 21s are and 25s are. So in this case it will be minus 10 degree Celsius. Ladies and gentlemen, you saw that we can find exact value of that degree centigrade without using the expansion of the volume, which was one physical property. Instead of measuring the volume of a fixed mass of a mercury, we can use the length as well. We have to measure the length and then using this formula. Okay, now let me extend this topic to the graph as well. Ladies and gentlemen, this L0 and L theta is fixed. It will not be changed from L0 to L100. And similarly, 0 and 100 will be the unknown. Now, in this particular case, there is a theta. So we have to write L naught as at 5 centimeter. This will be 5 centimeter here. And then L100 will be at 25 centimeter. The 25 centimeter. L theta will be at 14 centimeter. So if we are finding this theta, these values, it will give you 45 somewhere between L naught and L100. So you can use this graph to find these values, and you can also use these mathematical formulae. General equation for the centigrade scale. General equation for the centigrade scale. Ladies and gentlemen, we use this for mercury length. We can use this equation to be generalized for resistance and for many other values, for many other types of this. Ladies and gentlemen, we are writing this equation. This is theta per degree Celsius. Instead of L, we are writing X, and that will be theta minus X 0, and then X 100 here, and then minus X 0 multiplied by 100. This is not X, this is multiply. So instead of writing this small l, which is specifically for measurement of length, but in many cases we are not using this length. So different physical quantities can be used which is measurable and reproducible. So in this case, X means generally. Here X is the physical property which varies uniformly with temperature. Uh, Example of X include R, capital R. When we are dealing with the resistance thermometer, instead of measuring the length, we have to measure the resistance of a wire at 0 degrees Celsius, at 0 point or ice point. And when we are finding these equation, we have to find the resistance of that wire at 100. Remember, ladies and gentlemen, let me explain this concept of resistance a bit. There are electrons which are moving in a wire, but there are lattice atoms which are vibrating like this, and they are stopping these red marked electron, and this is vibrating like this. When the temperature is less, then it means that the vibration is less, so resistance will be less at low temperature of this wire. This is a copper wire or of aluminium or platinum. This. So when we are increasing the temperature, the vibration is also now rigorous, and few electron will pass from these lattice atom. This will pass, this will pass, this will pass, not all. Resistance will be there. So we have to find the resistance at 0 degree Celsius or centigrade, and resistance at 100 degree Celsius. So we can generalize this formula for resistance. Also we can use it with the pressure as well. We can use this formula. Pressure is another quantity, physical quantity, which can be used instead of this L. We particularize this formula for length, and then we generalize this formula for resistance. So instead of X, I will write theta. Instead of X 0, we will write R 0, and instead of X 100, we will write R 100, and again instead of X 0, we will write R 0, r multiplied by this. So we can write all these things in that, and if we are generalizing it for graphical representation, the criteria will be the same, only the labeling will be different. So this will be 0 and this will be 100, and we will say theta per degree Celsius. In this case, you don't have to write L. You have to write X and whatever unit. Ohm is the unit of resistance, but you can use micro ohm, mega ohm, milli ohm. So whatever the unit is, we will. So this will be X naught and this will be X 100. So we will have to mark 2.1 is here and 1 we will mark as here, and then we have to connect these 2 points, and the temperature, the resistance of unknown wire will be on this line. For example, if we are saying that here we want to find the temperature, the resistance, so we have to extend this line and we have to connect that with the y-axis, and then this will be the x theta. So in this case we have to find the x theta value. Now let us do a work example on this to clarify our concept. And this work example is 8.2. This work example is 8.2 and it is on page number 119. Ladies and gentlemen, the question is saying a piece of metal wire has a resistance of 800 ohm at the ice point. So data which is given to us, they given us R 0 at a resistance at ice point is 800 ohm. 800 ohm. This is the symbol for ohm, which is the unit of resistance. At the ice point, at 810 ohm at the steam point. So steam point you know is R100 and that is 810 ohm. What they are further calculate the room temperature if the resistance of this wire is 803. If the resistance is 803, so R theta is equal to 803 ohm. Now using this formula we can find that R theta minus R naught divided by R100 minus R naught multiplied by 100. You have to memorize this formula by heart. So in A level they are giving the formula sheet in the exam, but still it is not till the recording of this video in 2023 and it is May 27. No information that whether they are giving, but they are telling us that in the future they will give the formula sheet, then you don't have to memorize these formulae, but at the time being you have to memorize. Okay, we are putting the value r theta, that is 803 minus r, which is 800, and r100 is 810, and again 800 is multiplied by 100. Okay, so in this case we are going to calculate, and after the calculation we will get 30 degree Celsius will be the room temperature. Here they calculated it. If you can calculate it, so that will be 3 divided by 10 multiplied by 100. So this 10 ones are and 10 tens are and 3 tens are 30 degrees Celsius will be the ultimate value of this. Ladies and gentlemen, we are getting uh, late. I think very important topic, that is the Kelvin or absolute scale, is the next topic. Let us leave it for tomorrow, and tomorrow we will continue that and we will discuss very important phenomena that is associated with the Kelvin scale. So that's it for today. Hopefully, you have understood the concept of measurement of this temperature on the centigrade scale. One thing I have to mention, that this is the specialized formula for a specific length, but this is generalized formula, and then we use specialized for resistance. One thing more I can say, that this theta per degree Celsius can be P naught minus P. First is P theta minus P0, then P100 minus P0 multiplied by 100. Now you will say that what is PP? Is the pressure. So if pressure is also used to change the temperature, high pressure, there will be one type of temperature, and on low pressure there will be length can change, pressure can change, and resistance can change the uh, temperature. So many other factors can be considered, but these three are mostly used in calculating of these things. So you have to keep these things in mind. Ladies and gentlemen, that's it for today. Thank you very much for watching. Allah Hafiz.